So we're going to build off of both lessons now, okay, which is what math does. But this time, instead of plotting one line on the grid, we're going to plot two, and we're going to notice something about it when we do it, okay? That's the foundational work. What we do right now is like the foundational work for this entire first unit for the next like 7 lessons after this one. Okay, so if you understand what this is and what this is doing, every lesson past this it spills off this. Okay, we just again, this might not be the fastest method to do this, right? We're going to show you the faster ones in the next 2-3 lessons. Okay, and then we'll build some word problems too, ultimately. Okay, so with this, we have this thing called the POI. Okay, it's the point of intersection. That's where two lines cross each other. That's a very unique point, and it's very special. Okay, and it answers some questions for us. Okay, but we're going to use the graphing method. Okay, so your success criteria for being able to do that is to be able to plot the two lines using y equals mx plus b, which means your lines better be in y equals mx plus b. Okay, so if they're provided in standard, you better switch them. Okay, and then identify where the two lines cross, and then actually contextualize or provide meaning to what the POI means in that particular situation. Does that make sense? Okay, so a linear system, okay, is a set of linear equations. Could be 2, could be 3, could be 4, 5, right? We're only going to do 2, okay, but they represent relations between two variables, okay, the same two specifically. So you'll have x's and y's typically is what you'll see, okay? And then to solve a linear system, we're going to find the point of intersection, okay? So it'd be nice for you guys to write this down, point of intersection in full. But I don't expect you to write point of intersection every time. You can write POI. Okay? The point of intersection is the solution, which will mean more once I show you, but it's the solution to the system of equations, okay? Which makes it very unique relative to the rest of the points that fall on the graph, okay? It's basically the point that satisfies both equations. Okay, so here's what we're going to do. We're going to solve. The word solve means just find the point of intersection, right? Solution, solve. Find the POI. So what we got to do is apply our y equals mx plus b skills to produce the two lines, and we'll see where they cross. Okay, so what I like to do, if you have multiple colors, is I like doing the graphs in different colors, or like you could dash them or something, right? Just to see which one's which. Or you could just label them, that's fine too. Okay, but I'll do the first one in red, okay? So with the first one, my m value is going to be 3, and my b value is going to be 5. Okay, so that just means I'm starting at 5. So my y-intercept is 5, so I'm going to go on my grid. Here, I'll back out a little bit, sorry. Go to my grid. Here's my starting point for the red line, okay? And then my slope is 3 over 1. So it's rise over run. So I'm going to go up 3, right 1 from that point, okay? Up 3, 1, 2, 3, right 1. 1, 2, 3, right 1. Okay, that's about as high as I can go. Now what's the opposite of going up 3, right 1? In terms of direction with the line. So like most people aren't going to go like this. Right? They're not going to do this. That doesn't make any sense. Most people aren't going to do that. You got to go left, right? You're just going to do the exact opposite. You're going to go down and left. Okay? Which in math terms also makes sense because -3 over -1, the negatives cancel, m is still 3. Okay? That's how we know it's the opposite. Okay, so we're going to go down 3, left 1, down 3, left one. Okay, you keep going. Sometimes it's a good idea to keep going, just because we don't know where they're going to cross. Okay, that's probably enough. So what we can do here is I'll get rid of this. Okay, now if you're not going to use different colors, I would label this line as being y equals 3x plus 5, okay? And I'll probably give you a mark on a test for labeling it, okay? Just so we know which line we're talking about. When. That's going to be important later. Okay? And then we'll do this one in green, okay? We go find our y-intercept for this one. Okay, so m here is going to be negative 4 over 1. And the b value is going to be negative 2. Okay, so let's go find negative 2. That's our starting point for the green line. And I'm going to go down 4. 1, 2, 3, 4. Right 1, right? Because it's down 4. 1, 2, 3, 4. Right 1. Now, if I were to connect that, it would never connect. Wouldn't cross. But if I do the opposite of going down 4, right 1, which is going to be up 4, left 1, I should cross the line somewhere. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. You don't have to keep going. Once you get that, do one more past the point of intersection, that should be good, right? There you go. Now, I would also like to see do the lines just stop there, or do they go forever? They just keep going and going and going, right? So you'd like to have the addition of the arrowheads on the end, okay? To imply that they just go forever in both directions. Okay? So what's the solution then? That's kind of the important part. It's where those two lines cross. Right? So you could say the POI is at negative 2 and positive 1. Sorry, the other way around. Negative 1 and 2. Okay, it's right here. Okay, and then to check your solution to see if you're right or wrong, it needs to satisfy both equations, okay? So you're going to go, okay, well, my y value, well, I'm going to write the point here again. Okay, that's your solution. You're going to check it in both equations. So I'll write the equation that I'm doing, 3x plus 5. You're going to plug in 2 is equal to 3 times 1, negative 1, plus 5. So you basically have a left side and a right side, so it's 2 equals negative 3 plus 5. 2 equals 2. Good. That one works. Now you still have to check the other one because that may or may not be on the line yet. Okay. So if we check the other one with the green, we're going to go y equals negative 4x minus 2. I'm going to plug in the same point. 2 equals negative 4 times negative 1 minus 2. So 2 equals 4 minus 2. 2 equals 2. Okay. We know we're good. Okay. because that point satisfies both equations at that unique point. Does that make sense? That's how you check. Okay. So, just to throw a wrench in things, we're going to have to, well, we can plot the first one. We could do the first one in black here, if you'd like. Okay. M is equal to -2. B is equal to -3. I go start at -3. And my slope is going to be down to right 1. Okay, or up to left 1. Okay, we can connect those. Arrowheads on either end because it goes forever. And make sure you label it. Y equals -2x minus 3. Now we got a problem with the second one though. Because it's in standard form. Which Mr. Lin showed you on the sideboard how to do it with the intercepts, which is fine. Okay. But you can also plug in, you switch this to standard, or to y equals mx plus b, right? Which is what we did this morning. Okay? So you can go, I just need it just like above, okay? So we're gonna go, I'm gonna bring the 6 over to the other side. It's 3y, and I'm gonna bring the 12 over too. 3y is equal to -6x plus 12. Everybody okay with what I did? I just added 6x to both sides. And I also added 12 to both sides. Sorry, I have to subtract it from both sides. That's all I did, okay? And then I added 12 to both sides. And that's how I got to this stage here. Okay? Then I can just divide both sides by 3. They cancel, so it's y equals 6 divided by 3 is -2x plus 12 divided by 3 is 4. And I can go on my grid. M value is -2, B is +4. Okay? And then I go down to right 1. What happened? What happened with this question? Kind of got an issue, don't we? Are these two lines ever going to cross? They are parallel. How do we know they're parallel? Yeah? Their slopes are the same. Right? Where's the slope? Right here. So I knew these were going to be parallel before I even graphed them, right? Well, if they were both in y equals mx plus b, it's easy to see. It's not necessarily easy to see with it written in standard form like that. You wouldn't be able to see it. But as soon as you write in y equals mx plus b, you got two of the same slope, but different y-intercepts, they're never going to cross, right? So they can't have a solution because they never cross. They just go on and on like that forever. That's what they call parallel lines, right? Okay? Do we have any issues? Okay. So you can have, here are like kind of 3 situations you could have, okay? You can have one solution. That's where like the 2 lines kind of, that'd be like part A, okay, where they cross in one spot. Or 2, I'll draw a little picture here too, I'll move this up. So you can have one solution where like the lines cross at one unique point. You can have no solutions like what we just saw. Right? That's where the 2 lines are parallel. And we'll do this more tomorrow too. Or you can have infinite. How would it have infinite solutions? Yeah.
They have the exact same slope and intercept. They would just be the same line.
They could also be, yeah, you're right, scalar multiples of each other. Right? That's what we call scalar multiples. But so like, they're both on the same, you get 2 of the same line. Right? And we can see that when the, oh, you can't see yellow. The m's are equal. We'll do this more tomorrow in more space. This is just a kind of a quick, or on Tuesday. And the word equal could be like scalar, like 4 over 2 or something, instead of 2 over 1, right? We call scalar multiples. Okay? We'll do more of that. That's not a big deal. We'll do, that's the next lesson. Okay, so if that doesn't make sense at the moment, that's what we're going to do on 1.4, okay? The important part is that we've figured out how to graph 2 lines and where they cross. Okay? Now, if you guys turn the page over, okay, we're going to put words to like an actual like set of linear equations, okay? This is where the fun begins. Okay? So, here's what we got. Okay, so we got this company called Blue Heron. Okay, we got like the yearbook company, right? They print yearbooks and then they print them and then you pay this much for this many sort of thing. Like what our first question was this morning, okay? But you're going to have to come up with the equation to represent what's going on here, okay? So it's just giving you some information. Okay, so what you want to do is you're going to go, ultimately you want an equation that looks like this, y equals mx plus b, right? Okay, so with the first one, Blue Heron, they charge you $8,000 just to set up their machines, okay? And then past that, they're going to charge you $4 per copy. Okay, so when you guys look at this is important. When you look at this, these questions, word problems in particular, like earlier when we used the word sum or like is, and we associate math things or math terminology with specific words. So like the sum would be addition, or like is was equals earlier this morning. When I see the word per, that's a rate, right? So it's a rate of change. So when I see the word per, whatever number is in front of the per goes with the slope. Okay? So I know here, just by the $4 per copy, that the M value for the Blue Heron is going to equal 4. Now with lines, you only have 2 things to decide between, right? You've got the slope, and then you've got the y-intercept. Okay, but this company, when you contact them to get yearbooks printed, they say, okay, well, before you even buy any books, you're going to pay us $8,000 to set up our machine. That's your initial value or your y-intercept. Does that make sense? That's the B value, okay? Okay? So then your equation for blue heron is going to be y equals 4x plus 8,000. And then the miles ahead is the same thing. I see the word per. I go and isolate the word per copy. Right? That's my slope. M equals 3. B equals $8,400. Okay? Now sometimes you might be sitting there thinking, when am I going to use this? Okay? Which could be a valid question if you're thinking, okay, well, I'm never going to order your books and spend $8,000 to set up a thing, but there are applications in which you will encounter, right? So if you were to go rent a car, does anybody know how renting a car works? So if you were to go like to rent a car or whatever in town, right? Hertz or whatever, they're gonna charge you, just to rent the car, they might charge you like $50, right? And then on top of that, they're gonna charge you like 10 cents every kilometer that you drive. That's a line. Yeah, Paul.
Are there no calculators?
Maybe not in the class.
Did you figure it out?
Well, you could. I'm just saying, this is a little bit easier to just figure out, right?
Yes.
But the process of what we're doing is going to be like this critical thinking and applying things to word problems. You can't do it with some of the other functions out there. You guys have to start somewhere, right? So like when you start getting into like x cubes or x to the power of 4s or whatever, those are not, you cannot just type things in your calculator and figure out what the solutions are. Right? So we got to start somewhere, that's all. Yeah, it is possible to do it with lines because lines are the easiest of all the functions, right? Pretty straightforward, right? You can sit there and type it in, yes, but if you could do, ultimately what we're going to do on Tuesday is to use like a kind of a process to give us the answer in under 2 minutes once you get the hang of it, right? So now you might spend 10 minutes typing in numbers into a calculator to figure out the balance point. What we show you on Tuesday is like, it'll give it to you in under 2 minutes once you get the hang of it, right? But sometimes you gotta lay the groundwork to figure out, okay, this is actually what's going on, right? Trying to figure out this decision point. You know what I mean? So you could go, okay, well, for this one, this is sometimes can be a little bit like tedious, but the stuff we're gonna start on Tuesday, that's where things kind of get kicked into a gear. And I want to make sure everybody has the foundation, right? Okay. Now, you guys can figure out what's going on. You probably could have before as well, right? But now I have an actual equation. So these are going to be, your costs are going to be your y's. I'll do that below. All right. And then your number of copies are going to be your x values. Okay, just like what we did earlier. Plug stuff in, fill out the table. You're going to notice something when you do it. Okay, what's the starting value for blue heron? $8,000, right? And then what happens? You plug in 100 each time, right? Because you're ordering in bundles of 100, right? So 4 times 100 is going to equal 400, right? So plus the 8,000 equals 8,400, right? So that's what goes here. Now some of you may have noticed in doing some of the work that there's a pattern there. The pattern is the slope. So what happens from each y value as you go forward? From this point forward, what's going to happen? What's going on? To the numbers. Start at 8,000, I go to 8,400, I go to 8,800. I'm just adding 400 every time, right? We saw that in some of the questions, the tables of values, right? So you don't actually have to sit here and type like all this stuff in. You know, 9,200, 9,600, 10,000. Okay, if I go do the same thing on the other side, what do you think is going to happen? Just purely based on pattern. I'm going to start at $8,400, right? And from there, I'm going to go in increments of whatever 3 times 100 is. 300. Right, so 8,700, 9,000, 9,300, 9,600, and then 99. Can we identify for both things there the point of intersection? So you should see 2 points occur, or 1 point occur twice, sorry, in both tables. Yeah.
400.
Yeah. So when I order 400 400 yearbooks, the price is the same between both companies, right? So if you go to here, look, 400 and 9,600, 400 and 9,600. That's your point of intersection. So that's like a decision point, okay? Okay. So then you can graph these things, and then we're almost done. We'll make a conclusion. The important part is part D, okay? Let's go, fit this. Okay, so that little squiggly thing down at the bottom just implies that there's a break, but every 2 boxes you're counting up by 1,000. So every box is 500 essentially, right? The little squiggly just allows you to kind of get all the way up there, okay? And then on the bottom, we can kind of make our own graph. This should be a little easier. We can go 100. Okay, then we can plot both lines. So then I'll do them, sorry, I'll do them in their appropriate colors too. Okay, I'm just eyeballing it. You know the line's gotta be nice. Okay, there's the blue heron. Yeah, mate.
For the make a conclusion part, do we know like how many or what the population of the school is that they're getting leaderships?
Yeah, okay, so the nice thing about doing things like this is you get a generalization, right? So when we make a conclusion, It doesn't matter. That's basically the whole point of the conclusion, right? When we make the conclusion, and let's say here relative to Sydenham, a little bit bigger of a school, right? They're going to go with the company. If they need more books, they're going to go with the company that provides a cheaper price when you order more books. Does that make sense? Which is probably past the point of intersection.
So that's like, so I was just asking, like, should we then, for the conclusion, just say the pros and cons of both?
Yes. Yeah, you're going to say, okay, if I'm ordering less than this, I'm going to pick this company. If I'm ordering more than this, pick this company. What is the word this in my statement?
Textbooks.
Like, so, like my word, anytime I said the word this in my description, so if I'm ordering less than this, pick this company. If I'm ordering more than this, order this company, like get this company. What's the word this is the important part. Yes, but like specifically, what about the books? How many? Yeah. So it's the point of intersection. It's the deciding point. Okay, I'll talk about that in a sec with the line. Okay. You can do the same thing here. Oh, I started this in the wrong. Oh no, I didn't. This one starts at 8,400. Goes up by threes, right? My scale might not have been the best to see exactly what's going on here, but okay. So you know the two lines have to intersect. That might not be the biggest either. Through here. That's the important part. Okay, so what we were getting at when you make a decision, okay, depending if you're KC or Sydenham or whatever, and you got a different number of kids ordering textbooks, you're going to say, I'm going to stand here on my x-axis, and I'm going to say, okay, if I want 100 textbooks, which company am I going to order from? Remember, I was standing, so the decision is I'm going to stand here at 100, and I'm going to go up, and whatever line I hit first is the company I'm going to order from, right? If I keep going, if I go to the other end, like let's say I want 1,000 yearbooks. All of a sudden my decision has changed. I'm hitting the red line because it's cheaper. What I was getting at with the word this is in the middle, there's a tipping point, isn't there? The tipping point is your point of intersection right here. So if I order 400 books, doesn't matter if I'm KC or Sydenham, if I'm ordering 400 books, it doesn't matter which company I go with because the price is the same. That's point of intersection. Is it a little trivial? Yeah, this way it's kind of like, it seems a bit easy, right? That's a long time to do that. It also takes a lot of time to sit there and type in number into an equation, 5, 6, 7. You don't know where they're going to intersect, right? So you got to do it for both lines. What we're going to show you on, or what I'm going to show you on Tuesday, okay, will be an algebraic way to do this in under 5 minutes for you guys. How about that? Okay. It's going to attain for you that point of intersection in the easiest way possible so that you can make decisions about whatever. Does that make sense? Okay. That's it for today, I think. Okay.